Hi everyone, my name is Susinda Pereira and I work as an integration specialist at Links Cargo Care Group. Today, I'm going to talk about how to kickstart your migration journey from resource-oriented to event-driven architecture. Now, I know architecture migration can sound like a daunting task, but don't worry. Let's explore bit by bit. In this session, I'll be sharing a practical use case that can serve as the starting step of your journey, just like a pilot project. Awesome. Here's a quick outline of what we'll be covering in this presentation. First, we'll start with some important definitions related to our topic. Then we'll dig into why migration to event-driven architecture is important and the common challenges that we might encounter along our way. In the Be event-driven section, let's explore Soleil's recommendation and practical approaches for successful migrations. Then we'll talk about choosing a pilot project as a starting point, and I'll be doing a short demonstration of the process. Finally, let's discuss what to do after the pilot project and how to configure migration journey with some possible approaches. Let's look at some definitions to start with. Resource-oriented architecture. It is a software architecture and programming paradigm that focuses on designing and developing software in the form of internetworking of resources. Anyway, I don't think we need much explanation here as we all use it for decades and know what it is. Event-driven architecture. It is defined as a design where the flow of the system is driven by events. Events can be thought of as changes in state, such as user actions, sensor readings, or system notifications. In this architecture, communication happens asynchronously through events. When an event producer or publisher triggers an event, it is captured and processed by one or more interested consumers, usually referred as subscribers. Let's look at what is migration. First, it can refer to the physical movement of people or animals from one place to another. Second one, which is more relevant to us, which is the technology migration, defined it as movement of data or data operations from one system to another. With the above definitions, architectural migration can be understood as the process of transferring a system's architecture or design from one shape to another. So it's important to note that migration in both contexts involves moving from one location to another. While people and technology migration have differences, they also have similarities in terms of considerations and challenges. Okay, what is this? It's my boarding pass. It's look a bit weird, isn't it? It has both departure and arrival times, which you don't normally see in other boarding passes. I have to depart as soon as possible, and arrival date time is TBD, that is, has to be decided later. Unlike people migration, technology or architecture migration is not a one-off task. It's a journey which we need to plan and prepare. Another difference of technology migration is it is selective and flexible. Unlike people migration, where a whole family migrates together, in tech migration, we can migrate parts of the solution at our own convenience. Okay, welcome aboard. Okay, before we move on, let's see what we can learn from the people migration analogy and ask ourselves some questions. Let's talk about why people choose to migrate from one country to another. There could be several reasons why people make this decision. One of the main reasons is the challenges that they might face in their home country. These challenges could be economical, political, social, or environmental. Another reason for migration is the pursuit for a better lifestyle. People may seek improved standards of living or access to better education or healthcare, like that. They may also be attracted to the benefits and opportunities that other country could provide, such as higher wages or better social welfare. Peer pressure can also play a role in migration. When your friends or relatives have already migrated, it can create a influence on others to follow the same approach. Okay, so why we need a tech or architecture migration? Well, the people migration analogy applies here. If we see any issues, limitations, or challenges in the current architecture, we tend to look for a better one. That's normal, I guess, right? For example, resource-based architecture have known issues such as scalability, performance bottleneck, or increased complexity when it comes to implement complex business requirements. Another reason for architecture migration is the desire to benefit from the new architecture features. For example, we may want to adapt an architecture which is more asynchronous, loosely coupled, and real-time, which can offer increased agility and flexibility, such as event-driven architecture. Like in people migration, peer pressure can be a factor too. If we see other stakeholders or clients in our industry moving towards a new architecture or technology, it can create a sense of pressure to stay competitive and stay updated with the latest trends. Nowadays, enterprises use events and streaming technologies like Amazon, SNS, Apache Kafka. So we have a reason to be updated. When considering a migration, there are several key questions to ask ourselves. The first is, why should I migrate? It is essential to have a clear understanding of the reason and benefits of migration. If you don't have a reason to migrate, or if you don't see any benefits of doing so, you don't have to, because migration isn't for everyone. And there is no rule as such that you should adapt new technology or new architecture or whatsoever. Secondly, the migration can be a complex process with a lot of challenges, such as data migration, system integration, budget, skills, downtime, training, and impacts on the users. It's better to be aware of these challenges and develop strategies to mitigate them effectively. The next most important thing to ask is, do I have a plan? This includes a detailed roadmap, a timeline, resource allocation, risk assessment, and contingency plans. A comprehensive plan here can help you in managing the migration process efficiently, reducing risk and smooth the transition. Lastly, do I have the right tool set? Luckily, we have Solace here, and I'm going to discuss how Solace can use as the tool for the migration. You may already have experienced how it goes when you are trying to migrate to a new solution architecture, right? It's like a roller coaster of challenges, from dealing with time constraints, budget, and skills gap, to finding right tools, right people, with the training the team, managing downtime, and handling integration issues. Okay, but you know what? Possibly the trickiest part, getting everyone on same page. Convincing the team to embrace the new solution architecture can sometimes be harder. It's harder than you think. So we had to start from somewhere. Probably start with a small step. Do a POC, or maybe use event-driven architecture for a greenfield project. Yes, it's challenging, but nothing to worry, because you're not alone. There are enough material on the web to get you started. Solace describes 3 steps approach for becoming event-driven. The first step is to event enable your system. What does that mean? That is to break down and liberate your application to publish events as they happen, listen for them, and act on them. The second step discuss how you could extend the flow of events from systems in step 1 to your other applications, and how you could connect the rest of your ecosystem, such as your factories, fleets, vehicles, and stores into this event-driven world. As the last step, it has to be informed to the other interested parties, such as your customers or partners, in an event-driven manner, by alerting them about events of interest and also receiving events from them. So that is what is meant by alerting and inform. So I recommend reading the article in the link, as it discusses this in a great detail. How to implement event-driven architecture. Okay, Solace has a really cool 7-step approach for event-driven implementation. I highly recommend giving it a read, as it's packed with valuable insights on how to effectively design and scale your solutions. My focus for this session is the 4th step, that is pilot project selection. Getting started with a pilot project is the best way to learn through experimental before you put something into production. It could be one of your pain points, or you can choose an upcoming project as a candidate for the pilot project. When it comes to picking a pilot project, I think it is important to go for something that won't cause too much disruption or challenges to the existing system. After all, we wouldn't want to introduce something that ends up breaking the other system. I have chosen intercepting REST with EDA as my use case because I think it helps us to introduce event-driven patterns and technologies into our current REST-based system and gradually adapt event-driven architecture at our own pace. At a high level, I'll be setting up a mechanism to capture incoming REST requests and route a copy of them to a database using an event-driven process. This allows us to leverage the power of event-driven while still meeting the REST interface that our existing clients are familiar with. This scenario, the event is the use action that user calls the API. The inline application is the consumer who is interested and act on these events. Why I choose this project? What is the business use? Well, I had a couple of reasons to choose this. Apart from proving that events work, it has these reasons. As developers, understanding how our front-end and back-end systems communicate is crucial. By intercepting REST APIs, we can gain insight into communication patterns. By analyzing the data captured from these APIs, we can identify usage patterns, understand user behavior, understand any faults, and plan for scalability and performance improvements. So this approach helps us to optimize our operation and deliver a better user experience. Okay, let's dive into the demonstration. Initially, I have planned for an interactive demo, but since this is a recorded session, I'll be walking you through the demo using the slides to keep things simple and connected. Here are the prerequisites for this project if you want to try. First one, obviously, is you have to have a REST flow to interact with. And you need Solace message broker with few configs, which I'm going to discuss in next couple of slides. And you need ID such as Eclipse or IDEA or VS Code, and Java, Spring Boot, Maven, and other libraries. For the database, I have chosen Azure Cosmos DB, but of course, I think you can extend this idea to any other database. Most importantly, you have to have some time and freedom to try this out. In this project, we are using Solace in micro gateway mode. I thought it would be beneficial to talk a bit here before moving into implementation. When configured in micro gateway mode, Solace acts as a simple API gateway, enabling the use of request and reply messaging through the broker. Actually, this is one of the coolest features that Solace have, and one of our points of we considered when we choose our message broker. Solace micro gateway mode includes some cool features such as multi-protocol message delivery and request load balancing. It is important to note that Solace can be deployed either as a micro gateway or REST messaging service in a message VPA, but not both. And it's not a fully functional API gateway or API management solution, so don't mix up with the API management solution. Though it has some API gateway features, Solace does not recommend use it as an API management solution. For this solution to work, we need few configs in Solace. First, we need to have a queue to be used with the REST delivery points, also called as RDPs. And we need another queue for the listener. For both of these queues, we have to configure some topic subscriptions, which allows queue to receive messages that are published to topics. This feature enables guaranteed delivery of messages, as the messages published to topics can be stored in queues, ensuring that they are not lost, even if there are no subscribers available at the time of publishing. In our solution, we have queue to-dos, which is subscribed to get and post topics, and queue Java is subscribed to get, post, and the special P2P topic starting with slash hash character. This P2P topic is the topic where Solace gets the response back from the REST applications. So here's the configuration of the REST delivery point. RDP is the mechanism to configure REST messaging in Solace. You can configure one using Solace console by navigating to clients and then clicking on REST delivery point in the green button. This RDP defines a REST consumer, queue, and queue binding, where REST consumer defines the backend and queue binding defines which messages on which topic should be forwarded to which target path. So here's the config for REST consumer and queue binding. In this case, we have configured dummyjson.com as our backend and to-dos as our target path. Okay, that's it for the Solace configs. It is easy as few clicks, isn't it? In summary, what we did was we defined queues, topic subscriptions, RDP and its related configs to configure the REST messaging in Solace. Now let's move on to Event Listener app. Thanks to Spring Boot, Solace, and Azure libraries, I could implement this project with 3 classes and less than 200 lines of code. I have 3 classes. The log repository class handles the database writing part, and the message log class is the data model here, and Solace Sniffer is the main application. I have externalized the endpoints and credentials to application.properties file. So if you want to try this project as is, all what you have to do is clone the project and configure the application.properties file as per your environment. Here's the message listener part in the Solace class file. All it does is listen to the queue, which is defined by the log destination property, and creates the message log object out of it and pass that object to log repository class to save it. Here's how you can call this API. The first image here is how we could call the API directly, like it's just dummyjson.com. So we can use Postman or REST client to call this directly. The second image here shows how we can invoke it through Solace. Of course, you need a couple of properties when you call it from Solace. The first is you need to have basic code for the Solace API. And apart from that, you have to have the Solace reply wait time header. It's a special header, which tells the calling client to wait for the reply. Without this header, the reply from backend would not be routed back to the calling application, in this case, advanced REST client. So here's how it's saved in the database, the data in action. So I have 2 images here. Now that I have added 2 prefixes, REQ and RES, which is to identify whether it's a response or request, because in this application, I'll be capturing both request and response data. The first image shows the request data and the second shows the response data. So having these data stored in JSON format help us to query them using native JSON properties, which is one of the advantages using NoSQL database such as Cosmos. For example, you can query one particular request and its response using its ID or the correlation ID. Or you can query all the requests made for the to-dos endpoint using destination, or you can query all the requests made by a particular user, something like that. Further, you can search with multiple fields. For example, to find out how many times that a particular user, let's say user with user ID 6, call the to-do/add API. So likewise, you have endless possibilities with data engineering with this approach. Okay, I hope you got some idea about the pilot project. Now let's see how this exercise can be extended for our migration plan. Here, I would like to suggest a stepwise approach. As we discussed in the beginning of the presentation, we don't have to migrate all at once, or everything does not need to be migrated. Once we identify the possible candidates, we can make our plan as per our resources and our priorities. The first image in the slide is the REST-based architecture that you might already have. You probably have a mediation layer or API management in front of your microservices. As the second step, what we could do is introduce Solace in between as a REST gateway. As the third step, we can modify our microservices to support both HTTP and event-based communication. As we already did this for Solace app in the demo, I don't think it needs much explanation here. Here's what you have to do if you want to event enable your existing applications or microservices. This is for Java app, but I believe the concept is still valid for any other languages, as Solace provide many libraries in different languages. You can implement the same with other projects. Here I have introduced a message listener method and calls the same service method in the backend. The image in the top lists the extra dependencies needed for this implementation. Here I have added the step 3 again for the clarity. In step 3, we make our existing microservices to support both REST and events. In step 4, when our clients are ready for event publishing, we can ask them to publish them directly to Solace. In this instance, Solace needs to be configured in messaging mode. Note that this is only one way of doing it and not the only way of doing it. This might not work for all the scenarios, but I hope you got some insight to how we can use Solace for the smoother migration. The diagram in this slide is from Solace documentation, which defines a similar hybrid architecture which supports both request reply and event-driven patterns. In reality, we have to deal with both synchronous and asynchronous type of workloads or processing. Also, we have to deal with legacy systems while we are working on microservices for the new projects. In summary, we looked at why we need event-driven migration, a simple project to start migration journey, and how to continue the journey with a stepwise approach. I hope you like the presentation and find it helpful in implementing your event-driven journey with Solace. Feel free to ask any questions or send them through the Solace community or drop me an email. Thank you.